So we have some polynomials like yesterday. We are definitely going to be using Desmos for the entire problem to go over the warm-up and then also to go over the problems that we're learning about today. So first thing we need to do is to take the equation and type it in on Desmos. So y equals negative x to the fourth minus 5x to the third minus 6x to the second minus x. Did everybody get something that looks like this when they graphed it? Yeah, okay. So then we're going to be drawing a sketch of that just so that we have something to label. And the reason that I typically draw this sketch is so that I can have something to label for my increasing and decreasing intervals specifically. So at this point, your little sketch should look something like that. So as far as domain and range, we know that domain is left and right. Those are x values. Range is up and down. Those are y values. What do you notice if you look at your sketch for how far to the left the graph should go, how far to the right the graph should go? Yeah. Negative infinity on the left for an arrow, positive infinity on the right for an arrow. So domain is pretty simple. Okay, what about for the range? What do we notice about the range? How far down does the graph go? All the way down, right? It goes down forever. So we have arrows going down. So negative infinity going down. Does the graph go up forever? No, the graph stops, which means we have to figure out what the number is, and we want to figure out what the number is at the very highest point, which is right here. So when we look up there, are we going to use the x coordinate or the y coordinate? The y coordinate, because we're doing the range. So I'm going to go up there and click on that. Okay, the point is 4.248. So that's what I'm going to write into my range. And when I write that on my paper, is that going to get a parenthesis or a bracket? It's going to get a bracket. That's a point on the graph. I can put my finger on it. It's right here. Okay. If I do my increasing and decreasing intervals, I need my little stick figure. And when he starts walking, is he walking uphill or downhill? He's walking uphill. He walks uphill until he gets to this mountaintop, and then what happens? Now he's going downhill. He's walking downhill until he gets to this valley, and then what happens? And now he's going uphill again. He gets to this smaller mountain, and then what happens? Now he's going down again. So we're going to have 2 answers for increasing and 2 answers for decreasing. And when we do increasing and decreasing intervals, do we use x coordinates or y coordinates? We always use x coordinates for increasing and decreasing. So I'm going to go back to the graph and I'm going to look for x coordinates for this mountaintop, this valley, and this mountaintop. I need to write down all those x values. So I've got that one, and then this one's kind of hard to find, so I'm going to wait for a second until I can kind of isolate that point. So -1 for the valley, -2.656 for the mountaintop, and then over here, I'm going to kind of zoom in, and then there's my other mountaintop. That's the shorter mountaintop. So -point. Ooh, I zoomed in a lot. I got 4 decimal places instead of 3. Let me zoom out a little bit. There we go. -0.0094. Okay. 0.094. All right. So I've got all my x values labeled now. And then what is an x value for a left arrow? Negative infinity. What is the x value for a right arrow? Positive infinity. Okay. So for my increasing interval, I have the word increasing right here. The word increasing is between what 2 numbers? Negative infinity to negative 2.656. So there's the first one. And then what do I put around those numbers? Parentheses. Okay. And then the other word increasing is right here. And this word increasing is between what two numbers? Okay. And what do I put around those two numbers? Parentheses and a U in between because I have two answers. Okay. And then the word decreasing is in between these two numbers. So I need to write those two numbers down. Negative 2.656, comma, negative 1. Put parentheses around it. And then the other word decreasing is over here in between these two numbers. So I'm going to write those down. Put parentheses around it. Put a U in between. Okay. When it says max min, what is it asking for? Yeah. The mountaintops and the valleys. How many mountaintops are there? There's two. So I'm going to hit the home button to zoom back out again. I need this mountaintop. I'm going to write that one down. Negative 2.656, comma 4.248. Okay, so that's the first mountaintop I wrote down. Now I need to make sure I got the points for this mountaintop. Okay, so negative 0.094, comma 0.045. Okay, so I've got the two mountaintops written down. And then the valley, ooh, it's just negative 1, negative 1. Got the valley written down. Okay, so for that, there's our two mountaintops and our valley. Okay, how are we feeling about that? Good? Pretty good? Okay, let's try the next one. So we just need to type in the new equation. X to the third minus 4x squared plus 7. X to the third minus 4x squared plus 7. Okay, I'm gonna hit the home button so I can see everything again. Okay, so there's my graph. I'm gonna draw a sketch of my graph. Goes up, goes down, goes up. Okay. So there's my sketch. All right, for the domain, we know that's x's and we know range is y's. Okay, for the domain, how far to the left does my graph go? How far to the right does my graph go? Forever to the left, forever to the right. Okay, that one's pretty easy. What about the range? How far down does my graph go? How far up does my graph go? What do you guys see? Let me zoom out of the graph and then we might see it a little differently. Let's do it like this. Okay. How far down does the graph go? How far up does the graph go? Yeah, it goes down forever. It's got a little squiggle in the middle, but it goes down forever. And then what does it do? Up. Goes up forever. Okay, so it goes down forever and it goes up forever, but it's got a little squiggle in the middle. Okay, so this one, we can ignore the squiggle in the middle basically because this one goes down forever and it goes up forever. So we're going to say the range is also negative infinity to positive infinity. Now, this one was different. This one's going to have a squiggle, but this one literally goes down forever. This one would not have an arrow going up. It would truly just go down forever. But this one has that squiggle. It just goes up and down from the squiggle. Okay. So let's do our labels. We got our stick figure right here. And what happens with the stick figure? He's walking uphill. He gets all the way up to this mountaintop. And then what happens? He goes down. And then he gets to this valley, and then what happens? He goes back up. Okay. So this is what X value? A left arrow. Negative infinity. Here's a positive infinity. What X value is that? Right arrow is positive infinity. I think I said that. Okay, and then we need these other two X values. So let's look at Desmos. And I'm gonna zoom back in to normal. Okay, so we have an X value right here and an X value right there. So we have an X value of 0 and an X value of 2.667. So what should I write for an increasing interval? Yeah, negative infinity to 0. And I'll put parentheses around it. What's the other increasing interval? Perfect. Okay. And then what do we put in between our two answers? We put a U in between two answers. Okay. For the decreasing interval, we only have one answer. What should we write? We only have one decreasing answer. What is it? 0 and 2.667. Okay. Now we got to find the max and the min. So what's the max? 0, is it 7? Okay, 0, 7. And then what is the min? Perfect. Okay, so we got all of our answers written down. Let's go ahead and get our names on those warm-ups and get them turned in. All right. So the next part of the notes that we're on says to take this particular example problem, we're going to be finding the intercepts for that example problem. So we know in Desmos it's pretty easy to find intercepts because you just have to click on them. So let's go ahead and take this problem and plug it in. So we're going to be typing x to the third equals x to the third minus 4x squared plus 4. So we have 3 x-intercepts, and Desmos always has those as gray dots. And when we write them on our paper, we're going to write the full point when we write it down. So we're going to actually write down negative 0.903 comma 0. We're going to write that whole point down. And then we're going to write down 1.194 comma 0. And then we're going to write down 3.709 comma 0. So we're writing down the entire point. So your paper should look like this. And then for the y-intercept, that's another gray point on the graph. This y-intercept happens to also be the maximum. So on this particular problem, you found both the max and the y-intercept at the same time. As far as polynomial functions go, when we look at the definition of continuity, polynomial functions are always going to be continuous because remember, continuous means you can trace the graph with your finger and you don't have to pick up your finger to trace the whole graph. So if we look at any of these examples, we could start back on the front of the page. I can trace this entire graph without picking up my finger. So I can just trace it, got the whole thing before I picked up my finger. I can trace this entire graph before I pick up my finger. Even this kind of crazy one that I drew yesterday, I can still trace this whole thing before I pick up my finger. I can trace this one and then pick up my finger. I can trace this whole thing before I pick up my finger. So polynomial functions are always continuous. If they ever ask if the polynomial function is continuous, it's a boring answer. You're just always going to say yes. And then last, we typically describe what the end behavior is. And if you guys remember, end behavior is just saying what the arrows are doing. So we always start by saying as x goes to negative infinity, this is answering what the left arrow is doing. So x is going to be left or right. Since x is negative infinity, that's the left arrow. As x goes to positive infinity, this is us describing the right arrow. And what do you guys notice about the left arrow and the right arrow in this picture? They're both going down. So if I want to say that they are both going down, then I'm going to say that the y value is doing what? Negative infinity for both of them. The left arrow is going down, the right arrow is going down. So down, down. So at this point, our notes are complete. So let's look back at the assignment now. So the beginning of the back of the assignment first asks you to find the intercepts. So we're going to want to find the x-intercepts and the y-intercept. For the x-intercepts, there's not a magic number for how many of those there should be. There could be 1. There could be 3, there could be 4, there could be 2, there could be 5. It just depends on the problem. For numbers 19 through 22, it says determine if the graph is continuous. For all 4 of these, the graph is going to be continuous. For every single equation on the entire worksheet, the graph is going to be continuous. You don't even have to wonder it. Just if it's a polynomial, yes, it's continuous. Then it says to find the end behavior, which is just going to be describing those arrows. And then down here, this is the part that I wanted you guys to have the colors for. So we're going to go ahead and do the first one together, and then I'm going to let you guys do the last one on your own. So it says to look at this function. So what I want you guys to do is we're all going to type this function into Desmos, and we're going to use Desmos to help us figure out the color situation for this first one. So we've got negative x to the 5th plus 4x to the 3rd minus 2x minus 1. And the graph looks like this. And what I'm going to do is I'm just going to take one of my colors. And I'm doing blue first. And I'm just going to go over here, and on top of the f of x, I'm going to write y. I don't know if you guys remember, but f of x is just the y coordinate. Hold on. Okay, so we rewrote this as a y. So now the first problem says, where is the y value? Where is the y value greater than or equal to 0? So we're going to go to Desmos. And we're going to figure it out. If you click on the graph, Desmos will tell you what the x and the y values are. So we're going to click on the graph and have the graph help us figure out where is the y coordinate bigger than 0? Where is the y coordinate equal to 0? Okay, so what do you guys notice about this part of the graph right here? What are the y coordinates like? They're decimals. Are they greater than 0? Yeah, those are decimals that are positive numbers. Okay. Where do we find the decimals that are equal to 0? Or where do we find the numbers that are equal to 0? below the x-axis, that's where we have the y values that are equal to 0. On the x-axis. Okay, so that is where the y value equals 0 exactly. And then up here, we have y values that are positive. So if I'm looking for where the y values are greater than or equal to 0, I'm going to see y values that equal 0 on the x-axis. So here's a y value that equals 0. Here's a y value that equals 0. Here's a y value that equals 0. And then if I'm looking for y values that are bigger than 0, then those are going to happen above the x-axis. I can see other y values that are bigger than 0 over here as well. Those are above the x-axis, above the x-axis. Everyone see that? So I'm going to go back to my paper, and that color that I was just writing in, I'm going to put this color right here. And then I'm going to use that color on the paper. So I'm going to say here are the 3 places where the y value equals 0 exactly. And then here, right here, and right here, those are the 2 places where the graph was greater than 0. Does that make sense? Okay. The next question says, where is f of x negative? F of x means y. So where is the y coordinate negative? So now I'm going to look at Desmos. And I can click on the graph. I know that the y coordinate is not negative here because I was just looking at these points and none of these points had a negative y value. None of these points had a negative y value. I know that 0 is not considered to be negative. So where do the negative y values happen? Say it again. Below the x-axis. So if I click down here, all these y values are negative. I can see that negative for all of these. There's the negative y values. Okay, so I'm going to go back to my paper. And I'm going to say, okay, for this one, I'm doing green. And this is where my negative y values are. Okay. Now the last question says, where is f of x, which is really just asking about y. Where is y, or f of x, equal to 5? Where is the y value equal to 5? On my graph in here, is the y value equal to 5 in the blue part or the green part? The blue part. Is it on this blue part on the right or this blue part on the left? The y value equals 5 over here somewhere. Where does the y value equal 5?
Wherever the graph touches the 5.
Wherever the graph touches the 5. So I'm looking for a 5 over here. Wherever the graph touches 5 over here. Where am I looking for a 5? On the y. So here's the y value of 5. I'm looking for where the graph touches 5 right here. So if we go back to Desmos, what we want to see happen is we want to be able to touch the graph, right? We want to be able to touch this. And I want to be able to see that the y coordinate of the point that I touch, it should be 5. Okay, so we're going to have to go up. Am I closer to my y coordinate being 5? Yes. So it's like right in here. Okay, so this is definitely on the blue part, right? As opposed to like my green part. So it's right in here is where my point should be. So let's go back to our drawings. So my point should be right in here somewhere. Right here where the 5 is. Okay. So this is what you're going to do for the next problem, is you're just going to use a color to label where each of the things is happening. Does that make sense? Okay. All right, so today we are doing the back of the worksheet and then we are turning it in. Sound reasonable? The back. If you were gone yesterday, you got to do the front also. Okay. All right, go ahead and get working on that.